Hey man, this feels like an anniversary because it's the 20th episode. So I'm gonna make some fun today. I'm not gonna do anything special. 2 videos ago, I uploaded this video about magnetic water, anti-magnetic water. Today, I brought a copper pipe. That's all I can do. Boy, you can see right through it. Nice, very nice. And again, I brought my magnets. And I wanted to show something else. It's not as impressive as the last video. Like, you know how gravity works, you know? That was stupid. Well, you know how gravity works. But it's not the same in a copper pipe. Copper is very interesting. That was boring. Today I'm wearing my Illuminati shirt. And the reason is, I found this game. I have this game, it's called the Illuminati Game of Conspiracy. And it's about all sorts of Illuminati. It's a fun game. I don't even know why I'm talking about this game. I've played it once, because the rules is check. This is just the book about the rules of the game. It's a hard game to understand. Okay, check out the cool dice. Hello. Uh-oh. Where's the camera? Whoa! I caught them both! Blinded! Man, I definitely have to shave. I like these dice. These cards are so funny. Mega bucks. I'm rich. I'm so rich. Just look at my book. I don't know, it might be funny. Maybe you'll be interested by this stuff. Oh, these are some secrets I haven't showed you guys yet. Look at your drawing. Terrible drawing. It's about electricity. Yeah. Electricity. Helmholtz, Clausius, gradients. Helmholtz again. Another Helmholtz. Hey, vortex knots. I don't even know why I'm showing this. I don't know if you guys are interested in this stuff or what. I don't know. Maybe one day my house burns down and this is all I have left. So I should just record it. Because you forget the stuff you do. And once you read it back, you remember it. I showed you guys this before. What's this? This is about vortices. Yeah, I'm still working on this formula here. It's a formula that's about vortex rings going through a fluid. And what it says is the radius of the ring, as you can see here, this will be a vortex ring. It's about the velocity that the entire thing has in one direction. That's called translatory velocity. It's about the radius of the ring and the radius of the circulation part. It's a ring vortex. This is the core, that small thing. That is the irrotational vortex around it. This formula is all about that. I'm trying to use parts of quantum mechanics. Well, it's not really quantum mechanics thing. And I'm trying to recreate a vortex. This would be a slice. See? Size of A and G in this formula. A torus. A tor is in the French language a ring. Here we are back at that same old formula. Here I have a better drawing, airflow, a vortex. Just an unknotted vortex, so it has no knot, it's not a trefoil, it's just unknotted. Just a ring vortex. You can create a ring vortex by using a vortex gun. There are formulas about the amount of mass inside the gun and the amount of mass that exits the gun. in red here, so this would be a gun there, and it would roll up. It would start to roll. And so there are formulas how to recreate this, and I expect for some reason that atoms work in kind of this way too. They don't have a gun, but that they shoot photons out, and I can only imagine it going this way. I don't know how else. How else could you have a particle which is also wave-like? That's a weird thing, but that could be a particle, and the wave part could be the frequency of rolling. The size, the wavelength could be the length of the radius of a ring. And that could be wave and particle. Other formulas trying to recreate that formula. And I'm trying to put the speed of light on the A, I guess, and the fine structure constant on the place of R. But I haven't figured it out yet. What else do we have here? Some extra interesting parts about these vortices. Core of the radius is infinitesimally small when compared to the diameter of the ring. Then these formula count. This would say that in the middle of the vortex would be a small core, and that core would be insignificantly small compared to the rest of the vortex. That could be true when you think of atoms having a core all in the middle, all by themselves, surrounded by a flow of ether, which could look like, for instance, electrons if you have another reaction shooting light at it. Harmonics, it's the wave equations. A radiation pressure. Obviously I wanted to start something here and I gave up. Sometimes I'm not in the mood, man. For me this is a creative process. Physics is a creative process as well, for me. Like for others it could be a study, like you can try and become a real physicist, I guess. I'm kind of more of a hobby physicist still. Never thought of going professional because I need to have education and stuff, I don't know. Cat factors. Connected to a state of a system in finite or infinite dimensions. Cats can be multiplied by complex numbers. They use cats in quantum mechanics. Oh, this is some math I found. Very interesting. Might be able to use it once. I've been working on differentiating and integration. So these are functions and these are the derivatives of the function. I have this as a reminder for stuff. Here's some basic things all about integration. More integration. The main idea of the integration would be figuring out the area under a curve. So if you want to know the exact area underneath this curve, you can split it up in small amounts, small candles. To get a really good estimate, you can make the stairs, for instance, below the line and the stairs above the line, and you subtract the stairs below the line from the stairs above the line, and then you get the area under a curve. As you can see here, both. That would be beneath the curve and that would be on top of the curve. What else do we have here? Volume integration. Some stuff. I found at Dr. Physics A, his YouTube channel. It was a great help in finally understanding how the general relativity works. He has a great 2-hour video on the topic where he explains it in full depth. You will learn how to write all these formulas. He won't use it, but he will teach you what they're all about. And here it ends. I'm using my fisheye lens again. Whoa. It's kind of a vlogging lens. Hope you guys enjoyed this video. Thank you all for watching and see you guys next time. Whoa. Thanks you guys for watching. Wow, imagine me hitting the camera like